Okay, so we have a function. What's happening here is we have an object, I would assume, that's been thrown off a cliff 180 meters high, and it was thrown downward with a speed of 12 meters per second, and it's accelerating. This is a number that you see all the time in physics that represents how strong Earth's gravity is. So the object was 180 meters up, but it's falling at this rate right off the bat because it was thrown, and also it's going to pick up speed because Earth's gravity will reel it in. And when that happens, what you get is a curve that looks like a parabola, or part of one. The object will accelerate down faster and faster until it hits the ground, and then it'll stick or bounce depending on the characteristics of the ground. And this expression, S, tells us the position of the object, how high up it is, as a function of time. So if they want to know how long it takes for the object to hit the ground, well, if you're on the ground, your height is 0. And so we can take this expression minus 4.9t squared minus 12t plus 180 and say, where are we at when that equals 0? This is a quadratic, which makes it a mild nuisance to solve, but we have a formula that will do it for us. I'm going to multiply the whole thing by -1 because leading negatives bug me. 4.9t squared plus 12t minus 180 equals 0. So this is a quadratic where a is 4.9 and b is 12 and c is minus 180. And the t values we're looking for are given by what we call the quadratic formula. Maybe you haven't used it in a while, but you should recognize it. And if we put those numbers in, let's see what we get. Minus 12 plus or minus root 12 squared minus 4 times a is 4.9 times c is minus 180. I'm just going to put 180 and flip this sign because double negatives are not nice. And then we have 2 times a, which is 2 times 4.9. So, out come the calculators. 144 plus 4 times 4.9 times 180. The radicand is 3,672. And that's minus 12 plus or minus, and it's all over 9.8. Now, if we do the minus here, this says plus or minus, which normally means we're going to get two solutions, but one of those solutions comes from the left side of the parabola. It's way in the negatives, and it assumes that this object has been following a parabolic track even before it was thrown, which doesn't make a lot of sense. So I'm going to ignore the negative answer. It would be back here someplace, and it doesn't interest me. The interesting one is the positive one, which would be -2 plus the square root of 3672, and divide by 9.8, and I get 5.97. 5.97. So just under 6 seconds this object takes to hit the ground. Okay. That wasn't calculus. That's just general mathematical know-how and reminding you that the quadratic formula exists. Now we get to the good stuff. What is the object's velocity just before impact? Well, one of the reasons we care about derivatives, and that physicists get very good at derivatives, is that if you know something's position, 4.9t squared minus 12t plus 180, the derivative of your position means how fast is your position changing. And how fast is your position changing is exactly what velocity means. So if you want to find something's velocity, well, it's just ds dt, meaning the derivative of position. Here's the position right here, and its derivative is 2 times minus 4.9 t to the 1 minus 12, and that's it. So this is the object's velocity at any point in time. This says the velocity starts at minus 12, and every time the time ticks up by a second, your velocity increases by another 9.8 as gravity pulls you down faster. The 180, how high up you are, apparently has nothing to do with your velocity, and that makes sense. So now that we have velocity, the velocity just before impact would mean the velocity at 5.97 seconds. So how fast are we going right then? Well, it should be minus 9.8 times 597 minus 12. Calculator happens again. 9.8 times 597, and then another 12, 70.5. 70.5 meters per second is how fast we're dropping. And it should be negative technically because we normally use positive for upward and negative for downward, and this object is falling. It's definitely got a downward velocity. How long will it take the object to reach a downward speed of 20 meters per second? Well, this is the velocity at any time. So if you want your velocity to be minus 20, then you're asking for this to equal minus 20. And we can solve that for t without too much trouble. Add 12 to each side. Oops, sorry, minus 9.8t. Divide both sides by 9.8, and we get 0.82. It takes 0.82 seconds for this object to go thump. Or, sorry, not to go thump. This isn't a hitting the ground time. This is just a reach 20 meters per second time. So way up here at 0.82 seconds, we're already falling at minus 20. What's the velocity when time is 3? Well, we've got our velocity equation. We can use it all day long. Minus 9.8t minus 12 is the velocity. And they're saying when at 3 seconds, the time is 3. And we get 9.8 times 3, and then another 12. 41.4, negative 41.4, I should say, meters per second after 3 seconds of fall. Last one, what is the maximum acceleration? Well, we don't have acceleration yet, but calculus to the rescue. We can get it very easily. Just as velocity is how fast is your position changing, acceleration is how fast is your velocity changing, which means acceleration is the derivative of your velocity. Or, as we often say it, acceleration is the second derivative of your position. So to get it, you take the velocity and do its derivative, which turns out to be very simple. It's 1 times minus 9.8, t to the 0, which means don't even bother writing it, and then this term vanishes. So what this tells us is the acceleration of a falling object doesn't depend on anything. It's simply minus 9.8. And if you've taken some physics, you'll recognize this number. This is like Earth's gravity rating. It's a measure of how strong Earth's gravity is. So anything that's falling on Earth, unless it's got wings or an engine or a parachute, is going to fall at minus 9.8, and just to put in the units for people who will appreciate it, meters per second squared. Meaning you pick up speed at 9.8 meters per second every second. That's not only the maximum acceleration, it's the only acceleration. And you have that from the moment that you're let go until the moment you run into something.